Hello and welcome back to another video. Today we're talking about the standard normal distribution. Standard, we'll see how we go. But before we go, I guess let's do a joke. What did one plate say to the other? Don't worry, mate. Dinner's on me. Okay. All right. So, as I said, today we're talking about the standard normal distribution. Now, before we were talking about PDFs, and PDFs can come in all shapes and sizes. It can be kind of like a parabola. It can be kind of like a straight line. They can kind of be any curve. But the most common distribution is the standard normal distribution, aka the bell curve. This is what happens most of the time, and it looks a little bit like this. Now, don't stress, don't freak out. The next, couple slides of information is just theoretical information. It kind of lays the underwork, but I'll show you how they'll actually ask you the questions, and you'll see it's not so scary. Now, a couple things about that standard normal distribution curve. It has a PDF, a probability distribution function, and it's given by this thing here. Okay, now you will not have to memorize this. They will either give this to you or, you're not going to have to memorize this. It's not in the reference sheet, but you don't need to stress. That's just theoretically our exponential, but kind of like mirrored on the sides. That's what gives the bell curve function. Okay. Now, a couple things to note about this is if you do the math on it, the mean is actually right in the middle, right? So the mean is going to be right in the middle, and we can see there, your mean it's going to be 0, or if you want to be more specific, z equals 0. That's your mean. Your mean is right in the center, okay? The variance is also, if you do the calculations, it'll end up being 1. So it makes sense that the standard deviation is going to be the square root of 1, which again is 1. Okay, so this is why the normal distribution is nice. It's a lot of clean numbers, okay? Now also, because it is a PDF, if you did do that integration of your PDF of the standard normal distribution table, all the area underneath it, so that means all the area under here, if it's integrated, because it's a probability, it should give you an area of 1, okay? Now, the thing to note here is that's a kind of a bit of a disgusting integration. So whereas before we could easily integrate our functions, this one is a little bit more difficult, not impossible, but a little bit more difficult. So we've, for advanced anyway, you don't need to calculate that integral. But what we do is we either give you a table or we tell you this thing called the empirical rule, okay? So whenever they talk about the standard normal distribution, do not integrate, okay? I know before we have, but those were just for other probability distributions. If it says the standard normal distribution, we're going to calculate it in a different way. Okay, now the empirical rule is one that you've probably would have heard me talk about fairly often. And the empirical rule talks about this kind of idea that, okay, between, I should have colored these in before. So there's different areas here, okay? And the way that it works is the empirical rule says that if your Z score is between -1 and 1, it's 68%. The 68% of my whole probability is going to lie between -1 and 1 Z score. Okay, so that's what this probability is. Now, between the second one, that means we're between -2 and 2 this time. The empirical rule states that we've got 95% of all your scores between 2 standard deviations from the mean negative and 2 standard deviations from the mean positive. And for the last one here, we've got between -3 and 3 this time, and that's it. That's going to give us 99.7%. Okay, so that means between -1 and 1 Z score, we're going to have 68% of all scores. Between -2 and 2, we're going to have 95% of all your scores there. And between -3 and 3, you're going to have 99.7 of all your scores under there, remembering that the whole thing should total up to a total of 1. Okay, now let me show you how the questions actually come out. This is the empirical rule. And what we've also got here is we've also got the table. Okay, so this is how they'll actually more likely ask you the question. They'll say, use the table to find the probability that the Z score is less than or equal to 2.1. Okay, so the way this works is I'm just going to draw a little curve here. And I'm going to note that in the middle, that's 0. And if I'm going to be less than 2.1, I need to find a z-score of 2.1. Let's say 2.1 is here. And so that means the area, oops, let's stick on this side here. Oh, okay. The area that I'm really trying to find is all the area from here all the way up until 2.1. Okay, I know it looks like 21, but that should have been that should have been 2.1. Yep. So what I do is I look at the table here. Now z-score 2.1, I'm looking at this score here. Okay, so it's kind of like the 2 and then the 0.1, and then I end up at that value there. So from here, what it's saying here is the probability of me getting less than or equal to 2.1 is going to equal a probability of 0.9821. Okay, now very, very similarly, and I suggest that as you're doing these questions, actually get used to drawing out what they ask, okay? And I'm just gonna see if I can fix this because I don't want to keep turning it around. So, okay, let's see, we've got our straight line, we've got our normal, oops. Nope, still haven't fixed it. Okay, let's say I've got my normal distribution. Doesn't have to be perfect. It just has to be good enough for me to understand what's going on. Now this time I want it to be greater than 2.1. So let's say 2.1 is here. Now this time the area I'm trying to find here is this guy. I'm trying to find that area. And so this one here, there's, to be less, we just kind of pick the number straight away. But if we're more, and if I can find it here, Struggle Street. If I am trying to find it, the probability is going to be, now remember, the whole area under here is supposed to equal to 1. So in this case here, the easiest way to do this would be to be 1 take away 0.9821, because that's the same value, right? So that's whenever the number you pick is going to find the total area beneath it. Okay, so if I just want the top, I'm just going to do 1 minus, and that should give me something like 0.0179. Okay, so that would be your answer there. Now to continue on here, if I wanted the probability between 0 and 1.2, so again, it's going to be slightly different. Draw another kind of bell curve, assuming that I maybe drew it a little bit better. Okay, that looks a bit better. And I'm looking between 0 and 1.2. So let's say 1.2 is there. I just know it's positive. And that means I'm looking for this area in here. Okay, so if I've got that area there, what I'm trying to do is basically it's going to be the probability of, all right, this way, probability of Z is less than 1.2. That was horrible. Let me fix that. And it's getting really laggy because I put a photo in there, and it's going to be take away the probability of, I guess, the Z-score of less than or equal to 0. So probability of 1.2, let's take a look at 1.2. 1.2 would be this guy here, 0.8849. So it's going to be 0.8849. Take away the probability of 0, and if you take a look at the probability of 0, it makes sense. That's the mean. It'll be 0.5. Take away 0.5, and that's going to be 0.3849. Okay, and last one. This is probably going to require the most work here, so I'm going to give myself a little bit of room. Okay, again, 0 is your mean, so 0 goes right in the middle. And if I'm going between negative 1.4 and 1.9. Okay, now the way that negatives work is the normal curve is symmetrical, so it's the same on both sides. All right, so all I'm really trying to do is I want to find, I guess, the probability between of Z, let's say this way, between 1.4 and 0, and then plus the probability of the z-score, whoops. Yeah, let me try to fit it. So I'm gonna have to break it up into two little sections here. Fit please, between 0 and 1.9. Okay, so in other words, I'm finding the area in between negative 1.4 and 0. And then I'm also finding the area between 0 and 1.9. Okay, so doing the math here, what that should get us is between 0 and 1.4. I've noticed how I haven't picked the negative. So even if I did the negative, I'd be thinking of it in terms of positive. The reason being is it's kind of like symmetrical. So it'd be the same thing as saying the probability between 0, z 1.4 plus the same probability of 0, z, or z between 0 and 1.9. So in that case here, it's going to be 1.4. So 1.4 is this guy here, 0.9129, 0.91, is it 9129? 9192, 9192, take away 0.5 because of that 0, plus, and it's going to be the probability of 1.9. So in this case, 1.9 is this guy, 0.9713, 0.9713, take away 0.5, because again, the area just between 0 and that one. And whatever that is, put that in your calculator, that will give you your answer there. Okay, so a little bit lengthy. If you need to pause it, go back, rewatch it again until it starts to make sense. I guarantee you it'll make a little bit more sense the second or the third time you watch it. Okay, now, empirical rule, slightly easier. But what I recommend is that you would still draw it up. Okay, so the empirical rule, remember, is just the whole 68, 95, 99.7. So it says if the z-score is less than or equal to 1, what I would draw is, okay, there's my 1. And I'm trying to find this area here. Right? Everything from the bottom up, I'm trying to find the probability of scoring somewhere there. So in this case here, I remember that here, think of it this way. Everything on this side here, sorry about that plane, is 50%. That's half of your scores. And then this part here, I have to find what that little part is, but I remember that it's 68% between -1 and 1. So I know just between there, this one here is just 34%. So in this case, the probability that my z-score is less than or equal to 1 is going to be 50 plus 34. And so if you really want, it's 0.50 plus 0.34, so it's 0.84. That's the probability of me getting a z-score less than or equal to 1, okay? Now, if we've got something a little bit more complex, we've got between -2 and 1. So this one here would be between -2. So let's say there's your -2, and let's say there is your 1. Okay, slightly trickier. This just means that you're going to have to break it up a bit more. Okay. So the way that I would think about a question like this is by, well, we know that there is 34%, right? And we also know that, I'm just going to draw a little 2 there. So between there and there, I know that's 34%. So all I need to do now is I need to find whatever that is. We know that between there is 95%. So all I need to do is kind of like half it. So half of 95 is actually 47.5%. And so from there, I can see that my probability is going to equal to 0.475 plus 0.34. And I can see that's going to equal to 0. And again, just doing this in my head, 0.8 1, 5, I believe. Yeah, that looks about right. Okay, so you can kind of see it's a little bit about, I guess, logical thinking and just trying to work out, look, I know what 68, 95, and 99.7 is, and just trying to work backwards from there to figure out, okay, this is just the area I want. So you can kind of see the more that you draw your diagrams, the more sense it'll make. Now, last one here, find B when P equals to, when the probability of between 0 and some Z score B is 47.5%. Now that already looks like a familiar percentage. So again, draw out your normal distribution curve. And we know that between 0 and whatever B is, I know that there, just in between here and here, should be 47.5. So here I can kind of already see 47.5 was the same thing as this one up here. Okay, so if it was 34%, I'd know it would be between 1, but because it's 47.5, that's actually half of 95. And I know that 95 would be, I know that 95 is between 95% here would be if I had a Z score between -2 and 2. So in this case here, I can see that B is going to equal to 2. That's the Z score. Okay. Hopefully that makes a little bit of sense. Those are the questions that you'll be going through today. I wish you all the best. Now, technically, this is a standard concept. So if you've got questions, please ask them. Please email if you need to. And all the best. Rewatch this video if you have to. All right, catch you guys later. Bye-bye.